General relativity, step by step. We've got this easy transformation here, dx bar by dx, but here the bar's on the bottom, so I'm going to have to go to my transformation rule and restate it in terms of x alpha equals x bar alpha minus psi alpha of, and I'll just leave it in its components, x1, x2 and x3. Quite a very general transform here, but small. We're always keeping it to be small. Now, because we're differentiating with respect to the barred coordinate system, and these are unbarred x's here, I'm going to have to rewrite those in terms of the x's. Alpha of, what's x0? Well, from this rule here, it is x bar 0 minus psi 0 of some stuff which doesn't really matter because it's second order. Yeah, we've got four equations here. We've got one alpha equals 0, 1, 2, 3, 4, but each one of these functions here is a function of four arguments, comma x bar 1 minus psi 1 of its arguments, x bar 2 minus psi 2, and x bar 3, of course, minus psi 3, blah, blah, blah. And what we seek is di x alpha by di x bar beta, which equals delta Kronecker delta alpha beta for this term minus di psi alpha by di x beta evaluated at x bar 0 through x bar 3 minus, actually it'll be plus, won't it, because of these terms here, plus higher order terms. Because I'm evaluating it, this is a Taylor series, it's a Taylor series, and I'm evaluating the Taylor series at a slight offset here, so that requires second derivatives which are small in second order of psi, so I can just ignore that. Well, that's nice. That leaves me the di x alpha by di x bar beta equals delta alpha beta minus di psi alpha di x beta, correct to first order. And what was the other one I had? Di x bar alpha by di x beta was equal to delta alpha beta plus di psi alpha by di x beta. Again, first order. So now we can start to do some transformation in terms of small transformations. What we're going to do is we've just got these small transformations. I'll give you some examples from classical mechanics in a few screencasts, but for the moment just observe that for small transformations, which are called gauge transformations or gauge transforms, we've got these two beautiful relationships here, one of which is exact and one of which is only correct to first order. So I'm going to stop there. Stop.